So this video is about the parabola, and you're familiar with the parabola, or can think of the parabola as this guy: y equals ax squared plus bx plus c. This is the, I believe, typically called the general form. And if you had me for algebra, I probably said, oh, general form. I don't know why we don't call it a standard form. Yeah, because there's information I didn't really consider or think about, and that's because we call something else the standard form. We also had the vertex form, which was, in my opinion, much more useful than the general form. But the general form looks like a polynomial equation. That's why we would call it the general form, I think, and its relation to polynomials. And so the vertex form looks something like this: ax minus h squared plus k. And if we write this just a little bit differently, which I presented to you if we went over this earlier, and or if you had me for algebra, I would write it this way, preferably. And in fact, this hopefully presents to you the idea that this h and this k function in the same way. There's not one that's backward and one that's right and one that's wrong, or one, there's none of that. They both function in the same way. The minus signs are part of our formula. This minus sign is part of our vertex form, and it's part of the formula. So that means that k and h, the values that sit here, whether they be negative or positive, become our vertex. And that's why this is called the vertex form, because now this h and k represent together the x and y coordinates of our vertex. So if you recall back in earlier this year, or if you had me for algebra or whatever, we talked about having this, and then also talked about inverse functions. So let's just examine the inverse function of this function, x squared. So the inverse function, we would take the f of x and change it to y. We'd swap x and y, and then we would solve for y. So you get y equals plus or minus the square root of x. But since that would look something like this, we eliminate this portion of the graph so that we have simply this part, in order so that by restricting the range, right, to be here on up, and we restrict the range, getting rid of the negative portion, and then this is now a function. So we could write it as a function, identifying that it is in fact a function, because now it passes the vertical line test, which before, when it had the negative portion or the bottom portion, it was not a function. So you are familiar with this to some extent as well. And so what we can do is we can talk about what is referred to as the standard form of a parabola, standard form for the equation of a parabola. And that would typically be this, equals 4p y minus k, and that's not squared. Now notice, if h and k were 0, meaning that my parabola was had a vertex at the origin, this would be x squared equals 4 times p times y. And if I divided both sides by 4p, I would get y equals 1 over 4p. Let's just think of that as some number x squared. So this starts to look like the other vertex form with a vertex of 0, 0. So I'm going to erase all that and come back to this first part here. So they're highly related and fairly straightforward, except for this 4p is an unfamiliar value. First of all, it's not in front of this where the a used to be. It's now over here. And so how does that relate? So the standard form of a parabola, if I were to graph it, looks like this, especially if it's x squared. It's going to look something like this, okay? And the curvature of that's going to be different for everything. It's going to have a vertex, and that vertex is at the point h comma k. Then I have this thing called a focus. and the focus is at h, comma, k plus p. Or in other words, this distance is equivalent to that p value up here. And so that's why we end up writing it this way. That value, p, means something to us. And in fact, it means even a little bit more. The distance from here to this line that I'm drawing underneath here is called the directrix. And the directrix is a line, and because it's a line, it's going to be represented as a function, the equation for a line. This one is y equals, and it's always going to be y equals, for a vertical one, it's always going to be y equals k minus p. Why? Because this distance is also p. So I'm going to take the k value, subtract this distance p, to figure out what this equation is. Now, there is a, technically equally possible probability that this is going to be an upside down parabola, which you think of as this, when the a value is equal to, well, I shouldn't write it that way. When I get something like y equals negative ax squared, when I get something that looks like this, negative ax squared, meaning that this number, the coefficient, is going to be negative, okay? Then my parabola is inverted or upside down, or however you want to think of it. Everything works exactly the same, except my p value is now negative. The signs in here, this k minus p and this k plus p, take care of themselves. And it's perfectly fine. There's nothing fancy. So you can simply memorize these relationships that I have written here. I'll underline them in blue. That the focus has those values, that the vertex has those values, and the directrix has those values. Or I should say that value, y equals. And that's the horizontal case. And the vertical case. This is the vertical case. And if I said, since I accidentally said horizontal, you know that there is also a horizontal case. This one is vertical. And I'll give you a summary screen at the end. There is a horizontal case, and that's the case where that's more analogous to our inverse function. So that's when I have y minus k, the quantity squared. So notice how the y term is now the squared term, 4p x minus h. So again, this is the part that's squared. So since that's squared, this really kind of looks like the square root of x, right? And so it's our horizontal parabola. So it looks like this. Okay? It still has a focus. So let's just call it F. This still has a vertex that's h comma k. And there's still a directrix that's like this line. And the distances to these are still p and p. Now, what do you think is true if p is negative? What happens if p is negative? What happens? And hopefully you're saying that, well, if the negative p took our vertical one and made it upside down, inverted it, then it'll take my right-handed horizontal parabola and make it left-handed. And that is the case. If p is negative, we get this left-handed parabola where this distance is still p, this distance is still p. This is my vertex with coordinates h comma k. This is the focus, but now it has the coordinates. Did I write those guys down there? I didn't. I have to go back and do that. H minus p comma k, and the directrix is x equals h plus p. And up here, the directrix is x equals h minus p, and the focus is h plus p comma k. All right? And again, I'll have a summary slide. Or you can hit pause and copy all this down. It should match up with the summary slide later. So what kind of tasks are you going to be asked to do? I'm going to try to put two examples in here. One of them, let's just make one of these guys up. Y minus 6 squared equals 16, let's say. Let's make it 16. I'm typically going to make that straightforward, meaning divisible by 4 to make the math easier. And then I'm going to have x minus, let's say, x plus 2. Okay? So the first thing I want to do every single time, no matter if it's the parabola, the ellipse, or the hyperbola, I want to ask, is this vertical or horizontal? First question every single time. Since my y squared term, my y is the squared term, then this guy is horizontal. This one's horizontal because the norm is for my parabola to be vertical, and therefore that's the x squared term because that's normally y equals x squared. So now this one's the y squared term, so it's my kind of opposite or different, I should say. And so I'm going to have either this guy or I'm going to have this guy, right? I'm going to have, I'm going to have one of those two. I don't know which one. You won't know until you figure out P. And I would tell you that the first thing you do is ask this question. First thing you do is ask this question. And the second thing you do is figure out where the vertex is. And the vertex is at the point -2, 6. -2, 6. Third thing you're going to do is figure out what P is. And so I take this value, whatever that coefficient is, I'm going to set it equal to 4P. And then I'm going to solve for P. So P is going to be equal to 16 divided by 4, which is 4. Note that this 4 is positive. So if that P value is positive, then this one is the guy that we have. And this is if it's -P. So I have a right-facing, a right-opening parabola. And so now I want to find the focus point. Focus. And then the last thing to do is find the formula for the directrix. Okay, so let's find the focus. But prior to that, let's draw a picture. I guess 3.5 is picture. Okay, so I'm going to plot the vertex. I know that, sorry about that weird noise. The vertex is at -2, 6. And I have a right opening parabola. So the focus is going to be out here somewhere. Equidistant from the focus to the vertex is the directrix. So my directrix is going to be some x equals. And my p-value is 4. P-value is 4. So that means if I'm going to travel this distance to the right from -2, 6, I'm going to get a focus that is -2, add 4 to go to the right. So I'm going to have 2, 6. And then the directrix, I'm going to take -2 and subtract 4. So the directrix is at x equals -6. Or directrix is the line x equals -6. And that's how we go from equation to graph. There's another problem that they're going to give you where you are going to have to complete the square. So they're going to give you a problem such as, let me just sketch out a vertical one. It won't do the whole problem. But if I had this, x plus 7 squared equals 3, let's say 32, y plus 2, then what is this, horizontal or vertical? You should say that it's vertical, my quote normal parabola, because my x is the squared term, so I got something that looks like this, or it's something that looks like that, one or the other. And which one is it? My p-value is going to be positive, so I know it's this guy. Okay? So I'm going to erase this. I'm going to draw this much better over here. Well, maybe not much better. And those are my 3 things of interest: the vertex, the focus, and the equation for the directrix, which is going to be y equals some value. So 2, I'm going to find the vertex, and the vertex is -7, -2. And so this is at -7, that's not, -7, -2. And then 3 was, I forget what 3 was. Oh, 3 was figure out what the p-value is. P is equal to what? So that's 32 equals 4p. So p is equal to 8. And so the distance from here to here is 8, and the distance from here to here is 8. 3.5 was draw a picture. I already have that done. 4 was find the focus. And the focus is going to be 8 units above the vertex. So I'm going to take -2 and add 8. So I'm going to be at -7, 6. And then the directrix is going to be 8 units below the vertex. So the vertex is at a height of -2. So I'm going to subtract 8 and get the equation y equals, what did I say, -2 minus 8. So that's -10. Okay? So that's going in both directions. Now, there is going to be something that's slightly more difficult. Hopefully you remember how to do this. I'm sure you do. I could be given a problem like this. Y squared plus 4y minus, let's say 8x minus, I don't know, 2. I'm going to end up adding, let's make that 12. Okay? Equals 0. And they want you to graph this, or they want you to find the focus point, or they want you to find the vertex, or they want you to find the vertex and the focus, or they want to find you the directrix, the focus, and the vertex. So either way, you need to turn this into the standard form. How do we do that? Well, you're going to have to complete the square with this. So I'll remind you how to do that. Y squared plus 4y plus some I don't know value. And I'm going to add 8x to both sides and add 12 to both sides to get this. 8x plus 12. Okay? Now, I typically write this out so that I can organize my thoughts. Y, that's positive, so I'm going to add some number, add some number. These two numbers have to be the same so that I get this, y plus some number squared. And so I want to figure out what that number is going to be. This number, so that I can have the same value here and the same value here, but then do the distributive property and get 4 right here, a positive 4. This has to be 2, and this has to be 2. But remember, the multiplication of these two values plus positive 2 times positive 2 is going to be that number. So this becomes 4, which means I just added 4 to the left-hand side. So in doing so, adding 2 there means I'm adding 4 to the left-hand side. I have to add 4 to the right-hand side. So this becomes add 4, and this becomes 8x plus 16. So now this side looks good. The right-hand side does not look good because I want to make it some number times the quantity, x plus or minus some value, right? So I'm going to have to factor this 8. So y plus 2, the quantity squared, equals, factor out the 8 from the x. I'm going to get plus 2. And now I have the center point, the vertex. I can figure out the vertex from these two values. I can figure out the p-value from the 8. And I can figure out the location of the focus and the equation for the directrix with the combination of those two pieces of information. So everything really centers on this vertex and that value for p. With that, I can figure out the other two pieces of information. All right. So let's go look at a summary of the parabola. That's that information right there. So if I have a horizontal one, I can make these calculations over here. And if I have a vertical one, I can make the calculations over here. All right. So copy that down. I think the 1050 class, I made an error on the board. I wrote something incorrectly. So copy this down, change your notes, etc., etc. The parabola. So here's your D1, 2.73. Here's your D2 at 2.73. And here are the values you can change. I can change my X0 and my Y0. Notice how this person is, I think it's Kevin Hopkins again. Oh, it's Jennifer Silverman. She's using X0 and Y0 instead of H and K. So like if I was going to make mine, I'd make them H and K so they're consistent with what we're doing, but it doesn't matter. She's just saying it's an origin point or a 0 point where we start, and so that's why she's an X0 and Y0. So if I make this 0, if I make the X0 equal 0, if I can. Oh my goodness. Come on. Alright, I can't make it that easily. And I make y0 equals 0. I'm at the origin, but again, I can't get this done. Wait, if I select it and tick it over with the arrow, maybe. Yeah. So I just made it the origin and made it 0, 0, right? That's how it should happen. If I had x minus 0, this one's vertical, so this is x minus 0 for p. I should write it the way that I wrote it before. X minus 0 squared equals 4p y minus k, right? If k is 0 as well, then I get x squared equals 4p times y. And so this is just a parabola with 0 and 0 as my vertex. And so the focus point, I can change that. She's calling it A, we're calling it P, right? So she has A and we have P. If I make that larger or smaller, if I make it 0, I get nothing. I think I get a 0, right? I get x equals 0. And or y gets a 0. I don't have a point. So notice that as I change this distance, oops, I don't want to do that. If I change this distance changes as well because these two distances are the same, right? And if I make them, oh, actually the A is not that distance. A is this distance. She's killing me. It's the same A as in the vertex form. So it's this distance here. But I would want to pull this out and make this a p value so we can see it. But note that this distance and this distance is staying the same. The distances here on the green segments are staying the same, and that's what's happening with the parabola. This A value here is equivalent to the A constant in our vertex form. It's just what she's doing. That's why she used A instead of P. So notice those things changing. So they're all related to this the vertex. So if I change this vertex and shift it up and shift it over, I guess I don't want to shift it that far up. It disappears. This acts independently and works the same way. I'm making it too small. So now, something else you need to know is if my p value is negative, much like when my a value is negative, when my p value is negative, what happens when my a value is negative? What happens to my parabola? It is inverted. It flips, right? And so if my p value is negative, it is also going to cause that to flip. So as I get to the negative a value and negative p value, it flips.